Hello,
Yes, sir.
can you all hear me?
Yes, sir, we can hear you.
Okay, all right.
Good evening, sir.
Yes, good evening. Very good evening. Okay, all right. So you all are from one place, right?
Yes, sir.
Yes,
How much do you like this subject?
that I think the best subject I like.
Okay, good. You have heard this name before, arithmetic?
Yes,
Yes,
sir.
sir.
So since it is the first class, I wanted to know what are your understandings regarding numbers. Okay.
Yes.
So when I say number, what do you think?
So whole numbers, natural numbers, integers, fractions, decimals, real numbers, imaginary numbers, rational numbers, irrational numbers.
Okay. So are all of you at the same level?
Yes, sir.
Yes,
We
sir.
are in the same class.
Yes, sir.
So okay, not the class. I meant uh, okay. So better I ask a question. What do you think? A number is a living thing or a dead thing?
Uh,
So,
Living thing.
it's
It's a unit used to measure or calculate problems.
Okay, that's usage. Does it live or does it not live?
it does live.
Does
so few live, few don't live.
Which one lives?
So like there's not according to biology, but live means it's there, like it is present. Like
Yeah.
it's written, but not living means it's not written, it can't be achieved.
It's in our mind.
Okay. Hmm. Yes. Any others? Any one of you want to share something? It some lives, some do not live.
Yes, sir.
Yes, sir.
Okay. What are your of course, they don't breathe like us. They don't walk like us, and still we have to have some standard. Right? What is arithmetic?
Study of numbers.
Study of numbers. Why should we study?
So to get
To
an
get
understanding
good
of
marks.
To get good marks, to get understanding. So I'll
So
tell you.
it's
Yeah.
nothing, sir, nothing.
So it actually asks for a general question. Whatever subject we study, why do we study? Right? Earlier you were having some classes. Now you are
Yes,
having
sir.
maths class. Why at all we should study?
To survive in our daily life.
To survive in the daily
Each
life.
one of them have a use in our daily life.
Hmm. Yeah,
The
you are right.
life has become so advanced that we need these tools to understand it.
Uh-huh. Okay. All of you are correct. All of you are correct. But I'll tell you one specific reason why we study mathematics. Okay. Uh,
Yes.
the thing is like uh, your brain. Your brain is made up of nerves. You have heard the nerves,
Yes, sir.
nerve cells, right? So when you study mathematics, your brain wiring becomes more complex. The way you solve one problem increases your brain wiring, and it simulates real-time experiences. Meaning, in the sense, you will never use numbers practically in the daily life, but the same type of problem solving which you will do in courses will help you in solving real world problems. Do you get the point?
Yes.
Yes, sir.
Yes, sir.
So for example, somebody asks and say that this is a quadratic equation, find the roots of this polynomial. Where is the use of the daily life? Nobody in the world will ask you for daily root of this quadratic equation. But knowing the working behind the roots, knowing the geometry of the roots, knowing the procedure to find the roots will make your brain wired in such a way that when you face a real life problem, your brain will automatically go to those experiences and suggest you the solution for it. Understanding?
Yes, sir.
Yes.
Yeah. So these all things are the more broader objects of behind studying mathematics. Of course, all the subjects have their own objectives in their own way. Mathematics has this one. Now, the study of mathematics has been divided into several zones. Okay. There are at your stage 4 or 5 major zones. One of them is a study of numbers, which you called as arithmetic. Another one is geometry. Okay.
Study of shape.
Yeah, study of shapes, circles, triangles, squares, all those. Have you heard about any other domain? Study of numbers, study of shapes. What
So
else?
algebra.
Yeah, algebra. Yes, of course. Algebra means standardizing it.
As
Yeah. So what else?
Hmm.
Study of like physical things like speed, sound.
Hmm. Correct. Very good. So for the starting, we will see firstly study of numbers, arithmetic. Okay.
Yes.
For okay, so you have already mentioned, you have heard about so many numbers, natural numbers and integers, rational numbers, all. Who created these?
It was just there.
They were just there?
Many people developed it.
Ah, okay.
So
All of
it's
you?
like it's not like it was there, so it was created by us humans to
It was
understand
developed.
it. Yeah, it was
It was
developed to
discovered.
no, it
Ah,
wasn't like it wasn't discovered, it was created.
Okay.
Like there's a difference between discovery and creation, right?
Yeah.
Math was always there.
Maths was always there. Huh?
No,
Okay.
so like I say maths was created by us humans to understand the world easier.
Of course. Very good. Hmm. Do you remember any names who might have created numbers?
Archimedes.
Archimedes. Okay. Anybody else?
So Aryabhat.
Aryabhat. Okay.
Ramanujan.
Ah, yes, yes. All very famous names. Hmm. Okay. There are several names. Yes, of course. And even it has a rich history behind it. Who created, for example, who created, nobody really knows. Secondly, where they were created, were they Greek, were they Chinese people, were they Indian people? Since we are Indian, of course, we can give ourselves credit to create the construction of the number zero
And infinity.
and infinity. But what about other numbers? Third
So, but
thing,
without zero, there is no other number. Like there's only numbers from 1 to 9. Without zero, there's something else.
11, 12, 13, 14.
Yeah, but
oh,
they all come after 10.
yeah, correct. So have you ever wondered, like, uh, how many ways we can write the number one? Like, when you draw the number one, some of us write the number just like a little vertical line, right?
To
And
draw a line at the bottom and a diagonal line
yeah,
at the top.
yeah, and some of us just make the diagonal and just a vertical line, no base, right? So you will realize that even to write the number one, there are many ways, and we all of us say that it is number one, right? No?
Yes, sir.
Yes.
Do you think that they were originally written in this way only?
No.
No, sir.
No, they were like Greek alphabets,
Yes.
Latin alphabets, Latin
Yeah.
numbers.
Yeah. So there, so now there are multiple things. First, how to write a number. Second, how to speak the number. Third, how to understand the voice of that number. When I say one, your ears interpret this vibration, sends it to your brain, and says, this is the vibration of the number one. So you get that I am saying number one. Yes or no?
Yes,
Yes, sir.
So if you look at these logical questions, right, you will find that it has so much behind it that we don't realize it often. Okay. There was a time when people struggled to interpret anything in terms of numbers. Okay. I'll tell you a very interesting story. Like initially, now you call universities and colleges. Initially, few hundred years back, there was a school called as School of Pythagoras. Okay. And people who studied there, they were called as Pythagoreans. So the objective of the school was to study numbers and bring the connections from the nature. So they would observe natural phenomena, natural settings, and interpret it in numbers. They used to follow one simple rule that everything can be interpreted in terms of numbers. which later they found that it is not really true. So one of them said that no, you are wrong. Okay, so Pythagoreans suggested something that according to us, everything cannot be interpreted in terms of numbers. At that time, there was a belief that no, everything can be interpreted as numbers. So they were taken on a boat, and one of them was thrown directly into the ocean as a punishment to say that you are opposing God, and that's why we are doing like this. And there's a lot of history behind. You will find anywhere if you search. Arithmetic is the study of those objects. The numbers which you see written in your notebooks, in your syllabus copy, in your textbooks, they are live, or they used to be live objects at some period of time. Okay. Understanding?
Yes,
Yes.
sir.
Any questions till now?
No.
No, sir.
Okay. I have one more question for you. Do you see, like, you know how to add numbers? You know how
Yes.
to multiply, subtract, divide, and maybe raise to power, and maybe take a root. Do you think is there anything else which we can do? Is there any other operation which we can utilize to uh, to experiment with any two numbers?
Yes, sir.
Logarithm,
Yes,
then like
Trigonometry.
trigonometric functions.
yeah. So I guess trigonometry, because every time I type two numbers and I type that log
Sine,
something,
cos.
yeah, it shows different answers. So I think that is also an operator.
Okay, very good. So let's say that theoretically, whatever operation is available in the world, we bring it and put it in a bag. Now, after putting every theoretical operation, do you think is there still somebody outside the bag
Yes,
which
sir.
you can
Yes.
create?
Yes,
Can
sir.
you can you create something which has not been created to combine two numbers?
It's
Yeah.
hard but possible.
So
Huh?
first we have to discover everything in this universe and find all the possible ways to calculate it.
Let's say we did it. We did all logarithm, trigonometry, inverse trigonometry, exponential, all of the things. What would you take to create a new operation to join two numbers? Correct? No, like somebody would have created addition sometime. Somebody would have created multiplication. Why not we can create?
We
So, but
can.
to create, there should be a relation between the two other two numbers. Like two numbers, we take two numbers, there should be a relation between both of them.
Okay, what else?
Like if there is no relation, there's no point.
Tarun, what do you think? Can we create some operation?
Much up. Never thought these ways.
You will?
Never thought of those.
Okay. Nitish, what do you think?
So it's So hard but possible, sir.
Possible, huh? Okay.
Like everything we think of has already been discovered.
Yes, sir. Yeah, exactly.
Exactly, sir.
You found a phone. Why are you going to think about finding
We
that phone?
invent something, we look it up Google, it's already there.
Correct. So whatever you do, it is already there. There is no sense.
Yes.
Okay. Fine. Next thing which I want to ask you is, you would have heard a person's quality that he is a very rational person, right?
Yes, sir.
Yeah. And there are rational numbers also.
Yes.
Now, since they utilize same word, rational person, rational number, do you think there is a connection between two?
Um,
Both are
no,
English words.
Yeah.
sir.
But why? Like rational number is also there, and rational person. Person definitely is not a number, and number is definitely not a person. But still, we use the same adjectives.
So we use it because the person might be different.
Uh-huh.
Like he's in the middle of this and this, like rational numbers, like let's say 1/2, it's in the middle of one. Sorry, it's in the middle of 0 and 1. So he's in the middle of that and this. He's in that.
Okay. So, Tarun, do you call somebody rational person?
No, sir.
Okay. Nobody has ever called somebody a rational person.
Yes, sir. Definitely done.
So, on what occasions you have said that somebody is a rational person?
When
What
they're
made you
like
say that?
Organized.
strong on their
Organized.
opinion.
Strong on their opinion. Okay. Yes, somebody said organized.
Yes.
So organized, what do you mean?
Get their things together, like schedule their time, like every time it's like
Ah,
a schedule.
They will already have a plan about what they're going to do.
Utilizing their time properly.
so let's do an activity. Huh? All of you Google the meaning of rational person. Say, what does it say?
Sir, it says having or exercising reason, sound judgment, or good sense.
Yeah. So those people who have reasoning and sound judgment are called as
Yes.
rational persons.
So,
Okay.
but for me, it says someone who is sensible and is able to make decisions based on intelligent thinking rather
Yeah,
than
that's called
on emotion.
even under.
Okay.
Yes.
So will it be okay if I say rational persons are wise person?
That's what Google says.
Now, rational
They can
number,
think properly.
they can think properly. Now, Google rational number. What does it say?
A number, a number that is expressed as the ratio of two integers where the denominator should not be equal to 0.
Hmm. So it will give that boring definition, right?
Yes.
But still, no, like logically, shouldn't we ask? They are utilizing same word, but do you find any connection between rational person and rational number?
No, sir.
No.
Yes, sir, because rational number is defined it as a actual value.
Okay.
Like you can know what it's conveying, know what it means.
I don't think you.
So, okay. The connection means there should be some set of words which are common in rational number and which are common in rational person description also. Right. Now let me say about this. What is the connection between rational number and rational person? See, I'll describe two events. Okay. First, rational person. A person is on a street. He sees that there are two ways, left and right. He thinks, where is his home? He moves towards right. Sound judgment, one side.
Yes.
Then rational number, let's say 4 by 5. Now, when I say 4 by 5, I know that there is an entity which can be decomposed into 5 parts, out of which I am taking 4 parts. Okay. This is also a judgment. There is an entity which can be divided into 5 parts, and I am taking 4 parts out of it. That is 4 by 5. Do you see the common thing? The judgment.
Yes, sir.
That is the connection between rational number and rational person. When you give a rational number, you know how many parts you are taking out of the whole thing. Okay?
Yes, sir.
Yes, sir.
Very good. You all have heard irrational number also.
Yes, sir.
Yes, sir.
Yes, sir.
Have you used the word irrational? Have you heard this? This person is having very irrational behavior.
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir. Yes, sir.
So irrational behavior and irrational number. Can you guess what is the connection?
They're not
They
clear
both
on
are-
their thoughts. They're so confused.
They're so confused. Irrational behavior, like they do like very weird things.
Understanding, they do not have a clear understanding.
They don't have clear understanding. They are
Like
out
whatever
of,
they say isn't logical.
yeah. They have very irrational behavior. We say like irrational numbers are also like that. We can never capture an irrational number. We can never actually write full irrational number. We'll always leave it with 3 dots. Right? You have seen this?
Never. Yes,
Also,
and non-terminating, non-recurring divisions.
So when you encounter any irrational person, you say no, that okay, fine, you go do your work. That means ...
Yes.
it's a
Every
recurring
number is like a person. Okay. There are 2 types of person: rational person and irrational person. Likewise, rational numbers and irrational numbers. Understood?
Yes, sir.
Now
Yes.
tell me, let me give you a situation. Okay. We go to a birthday party. There are 2 boys. Both of them are irrational persons. Okay. They have irrational behavior. They became friends. What do you think will happen when they become friends?
They will form a rational friendship.
They'll form a rational friendship. Sure.
The other irrational person won't find anything
Okay.
because both of them are irrational.
What will happen if you see that 2 rational persons are becoming friends? Is it a good?
Still be a
Same
rational
thing.
friend.
Yeah.
Be a good.
So is it a good thing or bad thing?
A rational
It's a good-
friendship.
They both can understand each
So when you see that 2 people are who are rational and they become friends, you can expect that okay, they will take good decisions, they will be good in behavior, they will be good in everything. But when 2 irrational persons become friends, it is going to be a chaos. It's going to be like a bomb blast. Anything we can expect will happen. Yes or no?
Yes, sir.
Yes.
Same thing is with numbers also. When you add two numbers which are rational, they will be a rational number. The sum of two rational numbers is always rational. But when you add two irrational numbers, the sum can be anything. It can be rational or irrational both. That means those two people which are having irrational behavior, either they can become a wise person having rational behavior, or they will be more chaotic than individuals. Okay.
Yes, sir.
Yes, sir.
Can you give me an example of two irrational numbers such that
Root 2,
sum is rational?
root 2 and pi.
Okay. So root 2 plus pi, is it a rational number?
I don't think so, sir.
No, sir.
It's not, but
Root 2 plus root 3.
no, that is also irrational.
Oh, so you want a rational sum?
Yeah, I want two irrational numbers whose sum is rational.
Root 2, nothing.
It's hard, right? Even
Yes, sir, it's hard.
Yes.
in natural world, it's very hard to find two people who are irrational behavior and their friendship is rational. Yes or no?
Yes.
Yes, sir.
Most likely they will always be irrational.
Yes, sir.
What about square root 2 and minus square root 2?
That's one.
Oh, yeah, they are
So what?
rational.
So what? What?
Square root 2 and negative of square root 2.
Yes,
So,
Add to
but
0.
it
The sum,
becomes it becomes a
a
zero.
rational.
0.
0, right?
Yes.
Yes, sir.
So 0 is rational or irrational?
Rational.
Rational.
0
Rational.
by 1.
Yeah. So just like you see in nature, you will find same things in numbers. The next time when you meet two people who are friends, try to see whether they are having rational behavior or irrational behavior. Okay.
Yes, sir.
Yes, sir.
Okay.
So, but we can't define square root of -1, can we?
So
Negative.
negative is outside the square.
It's
Just
not
like
square.
Negative square 1.
It's like 2 minus 2.
Root. Negative root 1. And
Okay.
root
It's
and
not
root get
two. It's not
cancelled. So it's
negative root. Negative root.
Okay. Okay.
the two things, either minus sign can come under square root or outside square root. I am talking about the outside one.
Okay, sir.
Okay, very good. Let me ask you one more question. Suppose you all like we always think in this way. 3 by 5 means 3 parts out of 5 parts of the whole object. Right?
Yes, sir.
It means we are under assumption that we can divide everything into 5 parts.
yes, sir.
Yes. Of course, you can
Yes.
say that I give you 10 balls. You can divide into 5 parts. Each part will contain two balls. Right? Is it
Yes, sir.
always
Yes.
possible that you can always divide everything into 5 parts?
No.
Yes, sir,
No.
but not equal.
Yes, but not equal.
Not equal. So, but in the
Sir,
case
we
of
can, but it will become a fraction. Sir. Like
it
you divide
becomes
one ball into like 9 halves, and then give like it'll be equal.
correct. So let's say I have a glass full of water. I want to divide it into 5 parts and then take 3 parts out of it. How will I do it?
Divided through
Take
ml, measure it.
and then pour equal amount in
Pour
every
it
glass.
equally in 5 glasses.
Correct. That means I have a mechanism. I have 5 individual units. I pour it in that. But when you try to do it physically, you would realize that some water is still in your glass.
Yes, yes.
It is still on the glass. That means you have not given the full quantity into those 5 units. Yes or no?
Nearly
Yes, sir.
impossible.
Then who
So
will
that's
account for
impossible, sir.
Be like 1 molecule extra, like
Yes, sir.
liquid on the glass.
So that is my question. That's my question. Now everybody says that you have 10 balls, you divide it into 5 parts, take 3 parts. Fine. I don't like balls. I like glass of water. Give me an example, give me a physical way of doing 5 parts division precisely without any errors. How can I get it?
Fill the glass completely, and then like if the glass has equal diameter at like all lengths,
Okay.
use a marker to like divide the length into 5 and mark it on the glass.
That's
Okay.
also approximate.
So let's say I did your method. I went, I did the marker thing, all that, and I came up with a problem. Problem is when I put the marker line has a width. It may
Use
be
a CD
small,
marker.
but still, if I see from binocular, it will still have a width. It may be small, but it will have a width. So, into which portion of that width I should consider that the above is 1 part and lower is 1 part.
The half of the width.
Use a syringe.
Use a syringe. Even if I do that and I bring a more strong binocular, that will also have a width.
So you have to find a pen which
Has
can
no width.
divide like an atom, sir. Like it is thinner than an atom.
Yeah, very nice. Do you understand what the thing is happening? Right?
It's impossible.
Impossible. In either way I try, I will have some wastage, I will have some errors, and I will never be able to take 3 parts out of 5 parts of a glass of water. Now, if I cannot
sir.
do that, how can I imagine that I will build a rocket and will send something to the space? I cannot just take 3 parts out of 5 of a glass of water. It's so pity thing. Yes or no?
Yes, sir.
You put more than required.
Take more than required. Yes, because we can take required and it doesn't matter even if we have something more.
So approximate.
Approximate.
So if we
And
think
the
it's
rocket
3,
will also approximately go and then like have some.
oh my God.
So like you have to take the approximate, then have this backup.
Use
for it.
computerized mechanism, like
Computerized
exactly
mechanism.
divided.
So should I pour water on the computer? Or
No,
computer
sir,
in,
like
in
use
the
an
water?
electron microscope and then like
Yeah,
put one atom each.
There's no way possible to do that. Correctly divide.
correctly done. Now,
It is possible if you have the time to count each atom in the glass of each molecule in the glass of water.
So what I'll do, I'll take one
Earth will
molecule
end
and
before
spread it.
Earth will end before that.
So what all you have seen just a few minutes ago is called abstract thinking. Okay.
What?
Pythagoreans abstract thinking. Okay. Pythagoreans used to think in this way. Every number represents a phenomena in nature. They wanted a correspondence between nature's phenomena and a number. So if you give a number 3 by 5, which phenomena in the nature describes it? If you give a phenomena in the
What,
nature,
sir?
so they used to think in this way, that if you are given a number, a rational number, they used to find a natural phenomena in the world which describes it. So 3 by 5.
Physically relates to
Yeah.
the
So
number.
like 3 by 5, which is the one which relates to 3 by 5 number? On the other hand, they looked at in a phenomena, for example, butterfly flying over a flower, which number represents? Okay, that was the thinking at that time. Okay, understanding?
Yes, sir.
Yes, sir.
So these all will be the things which you will be seeing in arithmetic. Okay. It's up to your perception. You think that numbers are living objects or numbers are non-living objects. Okay.
Yes, sir.
All right. Next thing which I want to tell you is number line. Do you know number line?
Yes,
Yes,
sir.
sir.
Yes, sir.
So if I say that all numbers are present on number line, then you will all agree, right or not?
Yes,
Yes.
sir.
Yes, sir.
But why only number line?
Because it's endless.
There are many endless things like XY plane, like air, space. They are also
It's
endless.
standard along the world.
Who set? Why was it set as the standard?
Probably like the Union of Maths set it as a standard.
Also, it has a
It has
definite value.
definite value. Okay. Why do we?
It's easy to use all around the world.
It's easy to use. Okay.
Time, like we can do it faster.
Hmm.
Like in 3 minutes, you can draw a number line.
Okay. So I like to play around with this number line. What I did, I went to a shop and asked for a number line. So they gave me a long thread. But when I brought it home, the thread was coiled and it was in intersections. It was inside other. Can I still treat that coiled thing as a number line?
Yes.
Yes, sir.
Yes.
So,
Will there be no defects? Isn't it that some number might have jumped out of it?
unless the thread
No,
is
sir.
cut, I think there'll be a difference.
Yeah, until the length of the thread is not changed,
Yeah.
you can just
There'll be
untie
no
it and
Okay. So you are sure that no number would have jumped out of the line when I had coiled?
it may have, like, if it's cut
It may
or
have.
pulled somewhere.
So then
cut or
Mhm.
Yes, sir. Only if it happens only when the thread is cut.
length is anything in the thread is displaced like a different. If it's same, nothing will change.
Okay. So if let's say that the length has changed and now it is a defective number line. Okay.
Yes.
Which numbers might have jumped out of
Infinity
The last-
rational numbers could have jumped.
infinity?
Rational
Infinite,
numbers.
yes, rational.
Unlimited, you can't count it. In
Can't count
that
it.
The end
small
is
space, that can be
the end.
1 by 1 zillion, 1,
Mhm.
2 by zillion.
So
So
is
it's
it that you
only
cannot
infinite.
count it or you don't want to? You can
The
count.
number line is infinite, and one part of infinity is also infinity. So infinite number of
So how can infinite amount of can we take numbers even further than the size of atoms?
Yes, we can.
Okay, then it's infinite.
There's still a
yeah, like
finite number of
half 1.1
numbers because of the
by
length of the grid.
zillionth of an atom is
Mhm.
1 by zillion.
It's still a finite number, right? So because the thread is not infinite, the thread is only a finite
thread
number.
is infinite.
Like length.
No, I brought
thread
the
is
whole. I brought the whole number line. So the thread is infinite.
Then there is infinite number.
One part of infinity is also infinity.
Okay.
So from negative infinity to infinity, any one number, a single number can
So
Yeah, no
no,
part
sir,
of-
there are infinite number of decimals in between 1 and 0, sir.
Yeah.
Infinite
if it
number
falls,
of decimals. What do you mean?
fraction.
So like, sir, the
0.0001.
longer you keep going right towards the point, like the right side of the point,
Mhm.
like you can go on forever.
1 by 2, 1 by 3, 1 by
Decimal
4, 1
point-
by 5.
The decimal
Yeah,
point
like-
increases.
And it can just
0.001.
go on and on.
So you realize, no, that there are many numbers on the number line.
Yes, sir.
Yes. sir.
Very good. Very good. Good. Now the final thing. Okay. Final. What is what do you really see when you go towards the right side, farther and farther of the number line? What do
The
you see?
value increases.
Value increases.
No.
Can you
Oh,
tell me? Can you tell me what is the extreme right end point of the number line?
Plus infinity.
Yeah, positive infinity.
Positive infinity. So what is the value of positive infinity?
Cos.
It's infinite.
there's infinite values.
So
It
it's
is-
one more than how much you can imagine, sir.
Oh wow. Okay. So it's like I give you any number, you add 1 to it, and then repeat the process.
Yes.
Yeah. And same thing you will tell for the leftmost end point if you go on the number line,
Minus infinity.
minus.
Negative 1. Negative.
So I just want you to know that these two notations, they're just notations. They actually describe the phenomena that you can never find the right extreme and you can also never find the left extreme. Okay.
Yes, sir.
They are not numbers, they are notations. They are neither rational numbers, they are nor irrational numbers. Okay. Which brings us to ask, who is a person which is neither rational in behavior nor irrational in behavior?
Not
A
a
whole
real person.
person.
Never
Yeah.
speaks.
Not a real
like-
person.
Not a real person.
Yes, sir.
Yes, sir.
Okay.
So
You think
because rational and irrational number come under real numbers.
so? If I
So-
ask neither rational nor real nor irrational,
Yeah,
they,
yeah.
Not a real person.
Yeah.
Very good. Very good. Very nice. Okay then. So we will continue tomorrow. Okay. And see some formal things in this zone. All right.
Yes, sir.
Okay then. All the best.
Yes,
Good
sir.
night.
Thank you, sir.
Thank you, sir.
Bye,
Thank
sir.
you, sir.